Left my mic on mute as usual. Um, let's see here. Hope everybody's doing well. I'm out here in California. It's really hot today. So hopefully um, you're someplace where it's a little bit cooler than Los Angeles. Let me dive right into it. Okay. Okay. Hi, everyone. I'm Adeel. I lead engineering teams that build testing infrastructure and quality platforms. And my prompter is not working. Give me 1 second. Okay, there we go. I think it's working now. Okay, hey everyone, I am Adeel. I lead engineering teams that build testing infrastructure and quality platforms. Oops, still not working. Give me 1 second, folks. Technical difficulties. All right. I am very confident things are working now. Okay. Hi, everyone. Once again, I am Adeel. I lead engineering teams that build testing infrastructure and quality platforms. I want to start somewhere other than a definition. I want to start with a thing that happened. So, story time. Go back a couple of years, give yourself a magic wand, and you get to wish away certain parts of your job and magnify others. Which parts do you pick? Hold your answer because this isn't a hypothetical question anymore. LLMs, coding harnesses, agentic workflows, this is exactly what's happening to the job right now, and it's happening fast. This is true for engineering generally. I want to narrow it down a little. If you go back to pre-Claude, pre-ChatGPT time, what is something you would no longer want to do as part of your job? Put that in the chat. Keep track. For me, that might be keeping track of selectors was definitely one that I did not enjoy. Okay. Let's narrow it down to SDETs and QA practitioners and 3 questions. What part of your job shrinks? What part of your job magnifies, gets more valuable, not less? And what do you have to do to stretch into something genuinely new? These 3 questions are the entire talk. I'm going to be answering all 3, and I'll be honest about the first one. Let me show you what made me think about it this way. Early in this AI transition, I was watching a team build an internal AI chatbot, the whole feature built and tested with AI agents start to finish. The demo to stakeholders went really well. People were really excited about it. And in that room, one of the engineering leaders asked a completely ordinary question, which is, how will it perform under load? The question sent the team off to run load tests. They found multiple performance bottlenecks and they fixed them before a single beta user ever touched it. And this team had been careful. They had observability on cost, on behavior. They just hadn't thought about load. Now, who caught that? The person who caught it wasn't an AI specialist. They knew software and they knew users. And to be fair, the models and harnesses keep getting better at catching this on their own. That's real, but the pattern repeats anyway. The person who catches it, almost never the person who knows the most about the models. It's the person who knows the most about how software actually fails. And just similar to that person, that this we have a title for this. This person is you. That's the job description. An SDET is a software engineer who lives in the quality space. You own frameworks, you shape strategy, you make sure teams get fast, trustworthy feedback when they ship. The role doesn't get replaced, it gets promoted if you add a few specific things. So that's why I'm here to hand you quick word on who's talking. Once again, my name is Adeel. Quickly, over a decade in automation, CI/CD, Python test frameworks, across backend, front end, and performance. And I make AI for engineers content on YouTube on Adeel on Tech. That's the bio. Let's get to the useful part. Here's the picture I want in your head for the rest of this session. This is the whole talk in one picture. At the bottom slab, There are 4 columns: skills you already have. On top of each column, a new skill that stacks directly onto it, not next to it, on top. Then a band across all 4, which is what they add up to, and a roof where this is all going. I'm going to come back to this picture before every single section, so you always know where we are. Let's start with the part you're already good at. 6 skills. About a minute, it will move fast. This is magnifying parts of your job that get more valuable, not less. For each one, what it is, and one concrete upgrade. Not a reading list, one thing. The point isn't to teach you these, you have them. It's to show you which version of them is the most important one. Let's dive into it. Number 1. Okay. Bottom left, automation engineering. And I want to be precise about what I mean because it's not what most job descriptions say. The skill was never writing test scripts. It was designing the thing that scripts live in. And that's, you're designing API harnesses, you're designing the framework, and that's a design job. It's a job about making other people's work repeatable. Repeat that phrase, comes back in second half. If you want to level this up before agents arrive. Do this. Pick one stack and go deep instead of broad. Let's say Playwright plus API plus CI, whatever yours is. One. Then go unglamorous part, go kill your flakiness and make your framework extensible. Extensible meaning someone plugs in a new test generator into it without rewriting the core. Because in about a year, something is going to want to plug into it. Give it a socket. Number 2, drop a primary stack in chat. Would be nice for all of you on here to share what are some tools and platforms in the testing space that you are really good at. Okay, second column, test design and risk-based thinking. This is the one that is most undervalued, including by the people who have it. Boundary analysis, equivalent classes, state transitions. Underneath all of this is one judgment call that you make over and over, and that deserves coverage and what does not. That's not technique, that's taste built from beginning, from being wrong a lot. And it's the scariest thing in AI quality work right now. And here's the upgrade. Most of the risk model lives in your head. Get it out. Put it on paper, a checklist, a matrix, a page in the repo that says, these are the high risk areas, here's why, and here's what we always check. But also do it because a model can read a document, it cannot read your intuition. Written down judgment is the raw material for everything in the second half of this talk. Number 3, and this is my favorite one. Debugging and systems thinking. And I want to make a slightly aggressive claim about this one. The skill isn't reading logs. A lot of people read logs. The skill is refusing to stop at a symptom. Somebody says the test is flaky, and a good SDET says, flaky how? And that goes and then goes and finds the race condition or the shared fixture or the timeout. That refusal is the whole skill. Hold on to it. So sharpen it deliberately. Here's what that looks like today. We run browser testing agents and harnesses, which I think every company should have by now. And we get constant feedback about what's wrong with ours. More and more, that feedback arrives to me and my team in ways that are long, confident, AI-generated write-ups. Somebody runs our harness through Claude Code or Codex and comes back with a detailed explanation on everything wrong with that agent and why it's making their run flaky. So our automation engineers go debug it. 99% of the time, it's a prompt tweak. No change to the agent, no change to the harness. The symptom now shows up with very persuasive root cause already attached to it. And it is still usually wrong. So the skill isn't gone. is gotten harder and more valuable. The upgrade is to make it systematic instead of heroic. Write down your failure taxonomy, the 8 or 10 ways things actually break on your system: timing, date state, environment drift, third party, whatever yours are. Then every incident gets filed under one of them. And you notice which bucket is eating your life. That instinct, categorize the failure, don't just fix it, is the one I want you to carry into part 2. Number 4. Fourth column, CI/CD and fast feedback. And the emphasis is on the second half of that phrase. Pipelines, environments, dashboard, but that's just implementation. The actual job is delivering the truth about systems health to a human, fast enough that they can still do something about it. Or perhaps in the future, another system. You've been solving an information problem this whole time, not an infrastructure problem, which means the upgrade is about information, not the pipeline. 2 things. First, standardize how test runs are tagged, suite name, stages, boring high return stuff. Second, expose your quality signal somewhere a human actually looks, not a report nobody opens. When you eventually want to attach an AI-generated test suite or point an agent to your system, you need a clean surface to attach it to. A tidy pipeline with clear signals is the surface. A pile of ad hoc jobs is not. And the 5th one isn't a column at all. The last 2 aren't columns, they're slab underneath. One is collaboration, and the other one, super important, quality advocacy. I almost left it off the map, and it turned out to be one of the most important, biggest places to get a head start for anybody. Collaboration first. Practice explaining testing decisions as a story with a trade-off in it. Not, we found 4 bugs. Instead, here's what we covered. Here's what we deliberately didn't hear, and the risk we accepted and why. And you're going to need every bit of that trust, because soon you'll be walking into a room to explain finding that an AI produced to people who are not sure they believe it, right? You're always going to be finding, you'll always be fighting that, that uncertainty. And the second half of this slab is the one I almost forgot. Here's the one I almost left off. Reading code you didn't write and forming a fast, correct opinion about it. That has been the SDET's job for a decade. It's most of what you do. And right now, the share of code that everyone reviews but didn't author is going up and up and going up fast. So the whole industry is arriving at a condition you have been living in the entire time, right? You're already there. But something does change, and it isn't what people expected. The upgrade is not reviewing faster. Once volume goes past what you can actually read, speed stops helping. So you might have a lot of agents running and writing code. And at some point, you just skim more things badly. The skill is knowing what to look at when you can't look at everything. That's risk-based sampling. The same judgment, you decide which paths get a test, points at diffs, which files, which kinds of change get a real read, and get a skim on purpose with your eyes open. All right, that's the first half. But before we go, I have to level up on one honest thing. Remember the first question, what shrinks? I've been saying nothing gets thrown away, and that isn't completely true. Handwriting repetitive test, that shrinks. Manual regression passes, that shrinks. Maintaining a wall of brittle selectors, that shrinks, and honestly, good riddance. If that's most of your week right now, that part is going away, and I'm going to stand up. I'm not going to stand up here and pretend otherwise. What doesn't shrink is everything on the map, the judgment, not the typing. And the distinction is the whole thing. That's the foundation, 4 columns on a slab of collaboration and code review. And every single thing on it is judgment work. That's why none of it is going away. And that's why I could be honest with you a moment ago, and the parts are. Everything in the second half of this talk is built directly on top of specific. which is why boxes are sitting right there where they are. So let's fill in the empty rows. Okay, 4 skills. That half is slower, about 2 minutes each. This is the stretch half. For each one, I'll give you 3 things, what is actually is in plain terms, which of your existing skills it's built on, because I don't want a single one of these to feel like starting over, and the 3-step path to get there short enough, and this could get you started in a week. First one, top of the first column, prompt engineering for testing. And notice what's lit underneath it, automation and frameworks. That's not decoration, that's the argument. Here's what I mean by prompt engineering, because the term has gotten pretty mushy. Prompt engineering for testing is using prompts to generate test ideas, test data, and checks that are reliable, repeatable, and tied to actual risk. Those 3 words are doing all the work. Anybody can get a model to write you a test, right? There are lots of tools that allow you to do that. That's a party trick. Getting it to produce same quality of test on same area of your system next Tuesday for a different engineer, that's engineering. Because you've solved this exact problem before in a different costume. Here's the reframe I want to give you. You already know the difference between a pile of test scripts and a framework. Version, parameterized, reviewed, reused. A prompt library is the same object. Most people's prompt live in chat history right now. That's a pile of script stage. Turning that into something versioned and reusable isn't a new skill for you. It's the one you have applied to a new artifact. So the path is 3 steps. Foundation first, how models actually behave. Then testing specific patterns, scenario generation, negative cases, bug reproduction. Different jobs want different prompts. But the one that matters is 3. Ship a small prompt library for your own domain in the repo, reviewed like code. 10 prompts is plenty to start with. Column 2. Data curation and data corpus design. Sitting on test design and risk-based thinking, this is the tightest fit of the 4, and here's why. Data curation sounds like a data science job. It isn't. Not in this version. It means building the set of examples your AI testing runs against, real users, real flows, edge cases, inputs, and critically labeled examples of behavior that's good and behavior that's bad. Somebody has to decide what bad means for your product, specifically in writing. That person should be you. You've been making that call your entire career. Look at what that actually is. Equivalence partitioning is corpus design. You've been doing it by hand for years. When you pick a representative value for a whole class of input, that's exactly what you're doing. When you build a test corpus, same judgment, bigger volume. And the risk model becomes your labeling schema, high risk, medium, low. Those are tags on rows now. The nouns changed, the thinking didn't, which means you don't start from 0. You started from a decade of pattern recognition. 3 steps. Your sources already exist. Logs, the bug tracker, incident write-ups. Look into Jira, look into Confluence, look into Notion. The best corpus material is the building in your own history of being wrong. Structure is 4 columns: input, expected behavior, and risk tag, and also severity. Then build one focused data set and actually use it. Something narrow, API error handling scenarios. Use it to generate tests and to evaluate them. Column 3, this is the one most people are nervous about, and I think it's the one you are the most ready for. Model understanding and AI literacy, built on debugging and system thinking. And I want you to lower the bar on this one because I think it's set too high. You do not need to be able to train a model. You need to be able to test one. That's a much lower bar and much more useful skill in today's, at least for today. What you need is enough understanding to reason about failure, how the thing holds context, where it makes things up and why, the generative part of the Gen AI. How'd you measure whether it's any good? They're asking you to do the thing you already do, figure out how it breaks. And here's the specific instinct that transfers. Anyone, before we move on, anyone in the chat want to share like, hey, are you already testing AI features in productions? And if not, why not? Okay, let's see. Wow. Okay. So let's get back to it. Earlier, I said you never accepted it's flaky as a root cause. Do not accept it hallucinates either. Right? It hallucinates is a symptom. Retrieval missed the right document, the context window overflowed, and dropped the instruction. Temperature was set for creativity on a task that needed determinism. The prompt was ambiguous, and the model picked a reading. Those are mechanisms. Those are debuggable, and finding them is not model expertise. That's your job on new terrain. But knowing the mechanism does one more thing for you. Small example, visual testing is not a solved problem, right? If you're an SDET, you run into this all the time. I hit one recently where honestly, I was being lazy and multiple coding harnesses could not fix it. And I burned a lot of prompts and tokens that went nowhere trying to fix this small UI bug in my code. There was a cause. The context window was overflowing and my instructions, they were getting dropped. Once I knew that, I had two options that I didn't have before. First one, adjust and get to my tactical goal, or decide that given where the technology actually is today, that problem is better solved in a different way. The second option only exists if you know the mechanism, if you know the limits, and you're clear about your goals. The concepts are short. Tokens, temperature, determinism versus randomness, retrieval, evaluation metrics. That's a weekend to really figure out model literacy for the purposes of testing. Then the testing patterns, correctness, hallucinations, and the safety detection, guardrail validation, adversarial input, which is negative testing wearing a new hat, right? So just switch out the terms. Then instrument one AI feature on your own product, refine what good means, and run small experiments. Last column. Observability for agents, built on CI/CD and fast feedback, right? And the problem it solves is the one you solved before, maybe 2 a.m. on an incident, right? When an agent goes and does something on your system, you need to be able to answer 3 questions afterward. What did it actually do? Why did it choose that path? And did it stay inside the lines you drew? Right? The logs, the traces, and the metrics, but pointed at decisions instead of request. If you can't construct that, you don't have a testing agent, you have a rumor. And you have built this before. Right? The dashboards you built, you've spent years making on opaque automated processes, legible to a tired human at 2 a.m. That is the entire problem here. What changes is the payload. The number on the wall used to be pass rate. Now it's sequence of decisions. Same instincts. What would I need to see right now to know whether to trust this? That question doesn't care whether the thing running is a test suite or an agent. So here are 3 steps. Capture prompts, tool calls, decisions, state transition, errors. Make it viewable, right? Traces and timelines linking what agent did what happened. A wall of JSON is not observability. The instrument one simple agent, make it misbehave on purpose, and see if your traces explain why. If they don't, that's the finding. So that's four new skills sitting on top of the 5 you already had. Now stop treating those as 4 separate things. Corpus from data curation, Grader for model literacy, Harness from prompt engineering, sitting on your automation skills, Scoreboard from observability. Put all 4 together and you get one artifact, an eval. And this is what those 4 skills are for. They're leading up to evals. And I want to be precise about what an eval is because the word is doing a lot of work right now. An eval is a test suite for a system that doesn't give you the same answer twice, right? Same job as always, define expected behavior, run it, and get a verdict. One thing changes that assertion. Assert equal does not work when the output is different every run and still correct. So you swap out exact match for a grader, a rubric, a model judging the output. Check for properties instead of values. That's the whole leap. One substitution, everything around it you already know how to do. 3 steps. The third one is the one nobody warns you about. 1. Pick one AI behavior and write a grader for it. One behavior, not a suite. Run it in CI. On every change, that's your existing pipeline scale, point to the old infrastructure and somewhere new. Right? 3, watch what it cost. An eval suite is an API call, run on every commit, and it produces a bill. And right now, almost nobody owns that number, right? So that's about to be your number. You have to know how much it cost to do any agentic work, basically, right? You don't want that to just go to a black hole. So that's the second floor. But that's the question. But there's a question here that none of it answers. Right? Somebody has to decide what the agent is allowed to do in the first place, not how to test it, not how to grade it, whether it should be running at all. And that's not a fifth skill, that's a job. You want to become a quality architect. That box has been sitting up there, faintly since the start, and this is what it is. It's the move from writing tests to designing and governing systems that produces quality, right? Policies, guardrails, review loops, escalation paths. And notice it's sitting on the slab on collaboration and advocacy, because governance isn't a tactical act. It's a organizational one that you should be championing, you should be cheerleading. You can't govern something people around you don't trust you. You can't govern something people don't trust you about, right? So in practice, it comes down to 3 questions. 1, what are agents allowed to do in staging versus production? Those should not be the same answer. And right now, at most companies, nobody has written down either one. 2, who reviews what? When does a human inspect AI-generated test? And when can a human override an agent's decision? Human in the loop is super important. 3, what risk threshold forces a human into the loop, right? And please don't go build a governance framework. Start with one workflow. Write down the rules for that one. Add one real check, manual review, above some risk threshold. That document for one workflow is more governance that most teams have today. All right, let me close the loop. I opened at the start. So what shrinks? The repetitive typing, I was honest with you about that one. What magnifies? Everything in the bottom half of that picture. Every arrow starts there. What you stretch into, the top row, the band, and the roof. 6 things you already have, 4 to add, 1 thing to build, 1 role to grow into. And if you only do one thing after this talk, pick one column, just one, take the step 3 from that column, take the 3-step process from that column, the ship to prompt library one, or the one dataset one, or the instrument one feature, or instrument one agent. Do that one thing in the next 2 weeks. You'll learn more from finishing one of those than from reading all about all 4. And you already have the skill underneath. That's the whole point of this picture. So that's my time. Thank you. And with that, I'll open to any questions.
Thank you so much, Adeel. That was a genuinely insightful session, and the presentation was great too, I must say. So we can move to the Q&A session. I can see some questions queued up already. So we will take them up one by one. Okay, here's the first one. How should CI/CD pipelines change when AI agents are writing and deploying code?
Say that one more time.
How should CI/CD pipelines change when AI agents are writing and deploying code?
That's a really good one. I think one of the things to really consider here, from looking at it from not just an SDET perspective, but from the whole team, what you want to do, number one thing that you would do even before Agentic, you want to lower the risk on your highest priority features. So if you previously you had a test suite that was marked high priority or smoke test, you want to add those, and you want to have it run as early as possible, and you want that context available as perhaps even coding harnesses upfront change. So I think in a way they don't change much, but what changes is perhaps your speed and when you want to run things, where previously you may want, you might be waiting on to run them later because things were moving slower, but now things are moving faster. So you want to run them sooner and get feedback from those sooner. That's one place I would start with changes in CI/CD pipelines with AI agents writing and deploying code.
Okay. Okay, we can move on to the next one. Okay, how might the SDET skill stack change or evolve into 2027 and beyond?
Oh, that's a that's a really good really good question. I'm actually not somebody who spends a lot of time thinking about 2 years out. Things are changing so fast. I think the biggest thing is things are going to change in ways that we cannot anticipate. I think that's the biggest takeaway in general. So being flexible, aligned with business goals, being aligned with changing market for your company. I think those are even as whether you're an SDET, DevOps, backend engineer, front-end engineer, it doesn't matter. As engineering as a whole, those are things better to latch onto. So, 2 things, right? Be constantly learning and evolving. And the second, continue to align what you're doing with overall business goals that your team or company might have.
Okay, all right. Moving on to the next one. Okay, how do we enforce security policies at the tool and infrastructure level rather than relying only on system prompts?
This is a good one, especially, Fable is out, right? Again, the underlying models are getting so much better. One of the things was security policies and security testing. If I'm understanding this question right, it's very cheap to do now, especially even for tools that might be internal facing, right? So build it into your pipeline. I think most companies had already started doing that before this AI direction, right? So but now more and more, before you would get, what's the right word? It was expensive software that would do a security review of your code. but create a lot of noise, and it was difficult to separate noise from signal. But now it's much more it's much more easier. So have it run, PR commits, run your security policy on that code way early on. And if I understand that question, if this is about security tooling, run it on your PRs before a human even has a chance to look at it.
Okay, yeah, I think we can take one more last question. So let's. Okay, I am an SDET with 15 plus years of experience. What can I do to upskill myself to ensure that I stay competitive in the industry?
Yeah, I mean, I would say the number one thing is get really comfortable with evals. Like that's going to be something that will differentiate you. Think about it from if you're looking for a job, if you have a target company, right? If you look at it, um, whether you're building AI tools for production use by external customers or internal tools, all of it kind of relies on eval. So think of, before we might think of like, in browser automation space, right? Specifically Selenium and Playwright. Think of, in the AI world, think of evals, right? If you can get really comfortable with evals and you're able to demonstrate that in your resume, your conversation with a recruiter or a hiring manager, you're going to give yourself a leg up. So skill up on everything that I've pointed out today, but really focus in on, like, the output of that is you should be really comfortable around evals in a new and non-deterministic world.
Okay, I think that was all. We're done with the questions and answers. Thank you, Adeel. Thank you so much. It was great having you and hosting this session with you. After the session, I think a lot of us are walking away with a clear picture of which skills to hold on to and which ones to start building for the agentic era. So thank you so much. And thank you to everyone who joined us and shared such thoughtful questions. If you enjoyed this conversation, do share your takeaways on LinkedIn or X and tag us and use the hashtag TestMoConf. That's it from us for this session. Enjoy the rest of TestMo Conference. Thank you. Bye-bye.